So my students, real quick, another toilet paper roll joke. Why did the toilet paper roll get rolled down the hill? To get to the bottom. I like that one. Anyway, we are getting into more like intro to functions, and with functions, even just glancing on these notes, you can see that there's graphs. And so that's the key word, is we will be graphing. And so just starting right here at the top, there is a lot of terminology associated with the graph of a function. Many terms have names that are descriptive, but still work is needed to master the ideas. And so that's what we're going to be doing here, is working on some of the terminology. Now the first one, domain and range, we have seen it in earlier notes. And so what the domain and range was for the other graphs were for discrete graphs. Remember that discrete graphs have individual points. Okay, now this is a continuous graph if you take a look at this, and that's because it's made up of lines. Okay, it could be straight lines, it could be curved lines, or this one is line segments, and so again, it's just continuous, it's not individual points. To think of individual points, think of a scatter plot. Okay, so but again, this is continuous. So for domain, what you're going to do is we always start, so this side is positive x, so positive x. This side is your negative x. And so when we figure out our domain, we figure it out from left to right along the x-axis, okay? So let's go ahead and write down left to right. Now for range, we have our positive y and our negative y down there. And so for this one, we will figure out our domain from bottom to top. Okay, along the graphed line. So when I say along the x-axis or y-axis, it is along as it's increasing along the graphed line from bottom to top. Okay, so we're going to go ahead and write the domain and range of the functions using a single inequality. Okay, so for this first one, what I want you guys to notice that this graphed line starts at -5 on the x-axis. 1, 2, 3, 4, 5. That's how I know it's -5. So it is -5 on this x-axis. Now it is going to increase. We always write it from decreasing to increasing. So it starts at -5. So it is less than or equal to x. So just a reminder, if we're reading this, it's going to be all your x values that are greater than or equal to -5. It equals 5 because it's like a closed line, not a dotted line. And so again, we're going to scan it from left to right. So increasing, increasing, and then my domain stops right here. It stops at 4. Okay, so it is less than or equal to 4. Again, it's a solid line, so that's why it's equal to, not a dotted line. No open circles. I write the x in here because, again, domain is talking about left to right, which is how your x-axis works, okay? Now, range, the similar idea. We're going to go from bottom to top. So the very bottom point of this graphed line is -1 on the y-axis. So -1, less than or equal to y, because again, this is going to be all your y values that are greater than or equal to -1. 2, now the very highest point, so I go from -1 to the top. This is +5. 1, 2, 3, 4, 5. So I'm going to write down 5. It's going to be less than or equal to 5. So hopefully, again, this makes sense. I'm going to review domain real quick. So from -5 to +4. Okay, so this is all your x values. This is your domain, all your x values from -5 to +4, and this is the way we write it. For your range, these are all your y values from the very bottom to the very top, so -1 to 5, okay? And then again, it's going to be equal to inequalities because it's a solid line. There's no dots, there's no open circles, okay? So this is kind of your overview. We'll practice some more in a little bit. Let's go ahead and talk about minimum and maximum values. So minimum, maximum values, this one is nice because it is almost sounds like what it's supposed to be, your highest and lowest point in a particular section of a graph. So here we have this function, this y equals f of x, okay, that's our function shown, and it's over the interval from -7 is less than or equal to x, which is less than or equal to 7. So they're talking about the x coordinates, so from -7 to +7. Okay, we're going to find all the maximum and minimum values of the function, and we're going to state the values of x where they occur as well. So what we're going to do is actually find the absolute maximum, absolute minimum, okay? And so the absolute maximum, so let's write this down. This is going to be your very highest point of the graph. And so your very highest point is right here, okay? And so where it occurs at -1, 7, okay? Or we can write down when x is equal to -1, okay? That is your maximum. Now let's, your absolute maximum. Then we're going to find your absolute minimum. Okay, it is called the absolute, again, because it is the very highest and very lowest points. So your very lowest point is right here, okay? That ordered pair is -5, -1, okay? And it says, again, to state the x, it occurs at the x value of -5, okay? Now, what we're going to do, I have down here at the bottom are all your individual minimum and maximum points, okay? And so kind of a reminder that even though you have absolute minimum and absolute maximum, you have these relative where just, you know, these other kind of hills in the graph or curves in the graph. They're also known as turning points. So here's another vocab term to be aware of, is your turning point. Okay, so what we're going to do is we're going to state which one is what. So we're going to start with -5, -1. So we already talked about how this is an absolute minimum, so we can go ahead and circle that it is a minimum. Okay, so it is a minimum turning point. Then we're going to go to -1, 7. This one we already talked about is our absolute maximum, so we can go ahead and circle maximum. Then we have 2, 2. So here's 2, 2 right here. At 2, 2, this is also a minimum, okay? And then we're going to go to 5, 5. 5, 5 is a maximum. So hopefully, you know, the terms almost mean how they sound, how this is the minimum point of the graph. It turns and then goes upward. Here again, we have a maximum point. It turns and then goes downward, okay? So maximum, the top of a hill, minimum, the bottom of a valley, okay? Let's go ahead and turn our page. So now we're going to talk about something called increasing and decreasing, okay? So increasing, decreasing is how specifically the graph moves over a certain section. And so this is the same graph that we had for maximum and minimums. Okay, so as we look at this graph from left to right over a specified interval, so from -7 to +7, the function is decreasing if it goes down a hill. So this is a keyword. I'm going to highlight this, and if you have highlighter, go ahead and highlight it. So decreasing if it goes downhill. The function is increasing if it goes uphill. Okay, if you need to, you can think of it as a roller coaster. Decreasing if it goes down the hill, increasing if it goes up the hill. All right, so remembering that, this next part just tells you that we have the function y equals f of x over the interval from -7 is less than or equal to x, which is less than or equal to 7. So this is just kind of proper notation. Would you characterize the function as increasing or decreasing on the domain interval of -5 is less than or equal to x, which is less than or equal to -1. So when they talk about the domain, okay, so that means that you're going to focus on the x values from -5 to -1. So let's find -5. 1, 2, 3, 4, 5. So here is -5 to -1. Here is -1. Okay, so what we're going to do is it says over this interval. Okay, so interval is this section right here. So this section, and I can even kind of color it in with a pen. This section, is it going up a hill? And when we move, we always move from left to right. Okay, from left to right. Always from decreasing to increasing. So from left to right, are we going up or down? Hopefully you're thinking we're going up a hill, so let's write down that we are increasing because left to right, the graph goes uphill. Now, the proper notation is really the x values increase, as well as the y values. X and y values increase. Actually, yeah, we'll just leave that. If I have a change for my answer key, I'll let you know when I see you in class. All right, part B, write an interval over which the function is increasing and one over which it is decreasing. So that's what we're going to do, is we're going to find intervals, different intervals. So what I'm going to do right now is for increasing, this is again where I'm looking for an uphill. So like we had up here, here I have another uphill. Okay, and so we're going to focus on our x values. So it starts at positive 2, x, because again we're talking about x values, and it goes to positive 5. This is again where your x values are increasing. And I think this is what I meant to have that right there. Decreasing. So just again, find a section of the graph where you see it going downward. So it goes down here, it goes down here, and it also goes down there. So there are 3 different parts where we see that graph going down a hill from one turning point to the next. So just pick one. I'm going to pick -1 to positive 2. So from -1 to positive 2, my x values, or really my y values, are decreasing. This should be y, because my x values will always increase as I go left to right. Alrighty, let's go to the next section. So this is just kind of a little bit more practice with function terminology. So it's putting everything together with this one graph. Okay, so again we're looking at the interval -8 is less than or equal to x, which is less than or equal to 8. So we're going to write the domain and range using the inequality. Now, I see that I made a typo. Over here I talk about the interval, so it's this section, but then I go ahead and add it on the arrows. So if we do have arrows, we have -infinity to positive infinity, but we'll practice that again in a little bit. Let's just actually focus on this interval, so let's ignore the arrowheads on these notes for right now. So the domain starts at -8, okay, and it goes to positive 8. So this is, I can recopy that interval. It is the same thing as our domain, okay? So again, looking at your x values, it starts at -8, includes all the x values until positive 8. My range is going to be my lowest point to my highest point, okay, so along the graph. So my lowest point is actually 1, 2, 3, 4, -4. We're talking about y values to my highest point, which is 1, 2, 3, 4, positive 4. Okay. Find all the relative maximum and minimum values of the function. State the values of x where they occur as well. So let's just write this as ordered pairs. So we'll start with maximum, all of our maximum values. So my maximums are right here. Okay. So my first ordered pair is -6, positive 2, and my second ordered pair is 1, 4. Then let's do minimum. Okay, and so my minimum values are right there. And so let's go ahead and write these ordered pairs. So this first one right here is -3, -4. My next one is 4, -1. Okay, so just writing down the ordered pairs. And then part C, what are the absolute maximum and absolute minimum values of the function? At what x values do they occur? So this is your absolute max. We'll go ahead and abbreviate. This is your very highest turning point of the graph all the way up here. And so that is 1, 4. Your very absolute min, so your very lowest point of the graph, is down here, and that is the ordered pair -3, -4. Okay, and then we're going to just pick one interval where we see it is increasing and decreasing. So increasing, we're going from one turning point to the next. Okay, so from a min to a max, and we're going to write down that interval where it does. And so here's my biggest increase right here. So going uphill for my increasing, and that is, again, we always write it about the x value, so -3 to +1. And you know what? I do see a typo here real quick. It should not be equal to, and I apologize that I wrote that in there. Turning points will never equal that value because it will, at -3, it is also increasing, but if I look at it in the other direction, it's decreasing at the same time. So that's why it cannot be equal. Okay, let's go ahead and find a decreasing one. So decreasing, I'm just going to pick this interval right here. So again, anytime you see you go from a max to min, or when you see that graph looks like it's going down a hill, that is decreasing. So it starts at the x value of 1, and it goes to the x value of 4. Okay, so I know these video notes are getting a little bit long because of the terminology, but flip it over. I do want to try and hit maybe 2 of these examples. We'll do the rest in class, okay? So let's do the domain. So this first one is an interval. Again, your domain are your x coordinates, okay? And so my lowest x coordinate is -5, less than or equal to x, and my highest x coordinate, okay, is a +3. Okay, so even though it is high up, it is the highest x coordinate. Now my range, okay, so this is your very lowest y coordinate. That's -4, less than or equal to y. My very highest y coordinate is a +5. Okay, my maximum is my very highest turning point, which is right here. My highest turning point, and that is going to be the ordered pair of -3, +1. My minimum, okay, is my very lowest turning point, and that is 0, -4. Now, let's write down where we see increasing. So I see increasing in 2 locations, okay, and let's go ahead and write that down. So I have my first location is when x is -5, and I have this horrible habit of writing an equal to. It cannot, actually it can't equal this one. That's because there is no other, it doesn't connect with another turning point. But it does stop at +3. Do I have this right? I'm looking at my answer key. My answer key is wrong, so I apologize. It's making me make mistakes. So it's at -3. So 1, 2, 3. Yep, that's my x coordinate. Now for decreasing, this is where it goes down the graph. For decreasing, we have -3 is less than x, which is less than 0. I forgot my other increasing. So my increasing is at 0, which is less than x, and it stops, okay, and this x coordinate is +3, and it can equal that +3, okay? The last question I want to ask you guys, if this is a function or not. So let's go ahead and review that real quick. And so, yes, this is a function. Okay, and one more for me, please. The reason I want to talk about this one is because of the arrowheads. So what this means, what's my lowest x coordinate? I don't know my lowest x coordinate because of the arrowhead, so we're going to have -infinity is less than x. You can't equal infinity. And then my highest x coordinate is, again, my arrowhead tells me I'm going to keep going to the right forever, so it's +infinity. My range, my very lowest y coordinate, and this one is exactly -2, less than or equal to y. My highest y coordinate, again, my arrows tells me it goes on forever. Maximum, I have no turning point that's a maximum, so we'll go ahead and write down none. I do have one turning point that's a minimum. And that minimum, we're going to write it as an ordered pair, is 0, -2. I have one increasing. My increasing is from my turning point to infinity, and that's what we're going to write down. So my turning point is at 0, and it goes to infinity. And then again, I have one place where it is decreasing. For decreasing, I start at -infinity, and it goes to 0. So again, this is an example where we cannot equal 0 because the turning point is both increasing and decreasing. Since they are both, that's why it doesn't equal 2, it's just less than on those. Okay, and the last question for you, again, and we'll do this, is this a function or not? And you're going to say yes, it is a function. Okay, all right, thank you for these notes, guys. I will see you next time in class. Over and out.